What is up, guys? We are back here for another beautiful day in Puerto Rico and the first video in my series. We're going to be covering the concept design, so what it's going to look like on paper, and then do a little bit of a sanity check with the math and make sure that it's going to work and it's about the right size. So let's get into it. To get this episode started, I want to do a very brief history of what a hydrofoil is. So with that, it's basically a boat that uses airplane wings to fly above the water. And these things have been around for over 100 years, and there's been many interesting designs through that time. Unfortunately, they haven't had quite the recognition I think they deserve, but hopefully this video is one more thing to add to that. So there's a couple basic designs. There's surface piercing foils, which are wings that come out of the water, such as in this picture, and there are fully submerged ones where the whole wing is underwater. Now, the ones that come out of the surface are easier to control, but the ones that are fully underwater are more efficient. With that little introduction, I want to bring you guys into the concept design that I have, and you can see here in my Onshape studio the CAD software that the design I've gone for is a surface piercing foil in the front and then a fully submerged foil in the rear. Now, the design, of course, is just something that came out of my head and will very much most likely change before the final version is completed. But here, this kind of gives you the basic tripod shape that I'm going for. Now, if we take a look at the size of this thing, it's based on a standard stand-up paddleboard, which is over 11 feet. And this is about 3.35 meters is what I have marked here. And the wings, you can see, are approximately 1.5 meters wide. So the board is like 30 inches, and then the wings are going to be about 45 to 50 inches wide, so about 6 feet. Now you can see we take a front profile view here, and this is a mock water line. And so this shows where it's going to be sitting with the board in the water stationary. And then we switch over to one that shows like the flying height. So while it's moving, this is what's going to be submerged in the water. So the board will be sticking up about 2 feet out of the surface, and the wings are going to be supporting the weight, as you've seen in some of the historical photos. So you can see here, if we rotate the horizon in the model, this is the perspective of the board turning. So it'll have some roll aspect. And you can see here why the front wing would stabilize and roll. So now the inside that is lower has more wing in the water and will tend to push the craft back to center and make it level. And the fact that the other side of the wing is out of the water will make this effect stronger. So looking now at an isometric view, this is kind of the YouTube thumbnail thing. It does look pretty sweet from this direction, and again, you can see the tripod. The 3 points of contact will ensure that the board is stable in level flight. Okay, so for the sanity check portion of this video, the first thing we have to do is define our requirements, and that will be the carry weight, estimate the weight of the board, the speed we want this thing to go, and stuff like that. So in this case, here are the specs that I will be shooting for. Now, one of the most important things is the aspect ratio of the wing, because that determines how efficient your craft is going to be for any given wing size. So you start out with this airfoil shape that's a 2D side view, and you assume that it's infinitely wide. But when you move to an actual shape that has ends on it, so this rectangular wing, your aspect ratio comes into play and the actual performance goes down quite a bit. So in this case, if we take a brief look at my calculations, my desired span for the rear was 1.5 meters and the front was 1.2. And so I've tried to increase the aspect ratio as much as possible and got to a number around 6 2/3 for the front and 6.8 in the rear. I plugged these numbers into a tool that I've been using called Javafoil after I decided to use a NACA 4412 airfoil for many different reasons. And Got some fundamental constants that I needed to calculate the required coefficients of lift and angles of attack, as well as the corresponding drag coefficients. So with all these numbers, I'm able to tell at the end of the day what angle the wing needs to be at what speed to make sure this thing flies. Judging by the numbers, it seems that I'm quite in the realm of an acceptable wing area. And the reason I know that is because the angles of attack are required to lift the 200 kilogram carry weight out of the water are quite reasonable, on the order of single digits, 3, 4, 5, 6, 7, 8 on the front, and about 5 or 6 on the rear, approximately 6 to 8 miles an hour, depending on the parameters that I put in. The rear wing being submerged has a much higher efficiency than the front because it's not coming out of the water, and therefore we can generate more lift for the same drag off the rear wing. So it makes sense to put more of the load in that area. As well as that the driver or the pilot will likely want to be sitting towards the rear of the craft during operation. And it also helps with the flexibility of battery placement. Now I know there's some aero engineers rolling their eyes or shaking their heads or just patiently waiting to furiously type in a comment, and I am actually excited to see what you guys say about this and give me some feedback or, your opinion. Maybe quote an aero textbook for me. That would be fantastic. Hey guys, thank you so much for watching all the way to the end. Please leave a like, dislike, a comment, or anything you want to learn more about. I might have skipped over what you think I'm wrong about, so I'm looking forward to chatting with you guys about that stuff. Please check the description box for a bunch of the resources I use to make this project possible, as well as my Patreon link that will help us keep this project going to the moon and looking badass. So thanks again everyone, and I will see you next time for the scale model, design, and build. Here is some of the equations I used from an excellent paper linked in the description. Javafoil is the tool I used, linked in the description, and then I will have my spreadsheet linked for anybody who wants to take a closer look. So, cheers guys.